When you're drinking something and it's too strong, obviously you might taste it and go, ooh, that's too strong. And what might you do is you might dilute it, okay, or dilute it. So if you have some Kool-Aid or something like that and it's too strong, you add some water to it. And that's basically what we're going to be talking about today, is we're going to be talking about how do you make a less concentrated solution from a more concentrated one. Okay, and this happens very, very often in chemistry. When we purchase chemicals, we buy the really, really concentrated chemicals. Yet when we use them in classrooms, we typically dilute them so that students aren't using really, really concentrated acids, for example. So a lot of times, for example, we might buy 16 molar HNO3, but that's really, really concentrated, and I don't want to be using that, because if it gets on you, that's going to burn really, really bad, okay? And so a lot of times what we need to do is we need to take that 16 molar and we need to dilute it down to like 0.5 molar or maybe 1.5 molar or even down to 6 molar. Okay, and so in that process, you have to figure out the math of, okay, how much of this concentrated stuff do I need, and how much water do I need to dilute it down from the really concentrated one down to a less concentrated one. Okay, so here you can see, basically we're taking the same amount of the solute particles and we're just adding some more solvent, which again, most of the time is water. And so you can see those molecules are now more spread out in that solution. This one here is the more dilute version of that same compound. Okay, you can see the same thing happening here. This is the very, very concentrated one, and as you go from here to here, you get less and less concentrated. So this one here is the very dilute solution. This one is much, much more concentrated. Okay, so how do you do this? How do you figure out how much of the concentrated stuff you need and how much water you need? It's all based on this equation right here, M1V1 equals M2V2. It kind of looks like Boyle's law, P1V1 equals P2V2. Very different though. Obviously there's no pressure, and that capital M, M1 and M2 both stand for the molarity. So these are the initial molarities and the initial volumes. These are the final molarities and the final volumes. Okay, so let's just look at a couple of examples of these. So example number 1 says, what volume of 4 molar HNO3 is needed to prepare 60 milliliters of 0.200 molar HNO3? Okay, so notice here that we're starting with 4 molar. So that 4 molar is our M1. Okay, and they want to know what volume of that. So that's actually what we're looking for. We're looking for V1 in this case. And many times with dilutions, that's what you're going to be doing, is you're going to be trying to solve for V1. Okay, and then it says we're going to prepare 60 milliliters, so that's V2. And then we want the new concentration to be 0.200, so that's M2. So notice my equation here. It looks like this. Once I plug the numbers in, to get V1 by itself, I divide both sides by 4, and you end up getting 3 milliliters. Now, what that answer is telling me is that I need 3 milliliters of that concentrated solution. Remember, I'm taking a 4 molar solution and turning it into 0.2 molar. Okay, but that doesn't mean I just take 3 milliliters of that concentrated solution and pour it out. Okay, clearly there's more to it. So what this equation, what this M1V1 equals M2V2 equation tells you is it tells you how much of the concentrated solution you need. Okay, what it doesn't tell us though is how much water you need. Okay, and that's the part that, again, hopefully you can kind of realize, oh, I need 3 milliliters of the concentrated stuff, and I need 60 milliliters all total. If of those 60 milliliters, if 3 of them are the concentrated stuff, then I need 57 milliliters of water to get to my total of 60. Okay? So many times in the problem, they're just going to ask you, how much of that concentrated stuff do you need? But there's also that question of, how much water do I need to get to my new volume? Is you just take the difference between those two values. Okay, here's a second example. What volume of 12 molar hydrochloric acid must be used to prepare 150 milliliters of 0.125 molar HCl? So again, we've got 12 molar and we want to know how much of that we need. So that's our V1. Our final concentration is going to be 0.125 molar, and our final volume is 150 milliliters. Now, in this case, you certainly can convert those milliliters to liters. If you don't, it just means that your answer is going to be in milliliters, which is perfectly fine. So I need to solve for V1, so I'm going to divide by 12 on both sides. So I'm going to take 0.125, I'm going to multiply by 150, and then I'm going to divide by 12. Okay, and I get a V1 equal to 1.56 milliliters. I only need 1.56 milliliters. That's it. Okay, and then I still need to get to 150 milliliters though. So I need to take those 1.56 milliliters and then add it to about, again, not exactly, but about 148.5 milliliters of water, right? So the amount of water is going to equal 148 it's actually 0.44 milliliters, okay? And you put those two together, and what do you get? You're going to get your 150 milliliters. And again, now the concentration, it was 12 molar. Now your concentration has dropped all the way down to 0.125 molar. Okay, example 3. I think we've got 2 more here to do. Example 3. 32 milliliters of a stock solution of 6.5 molar H2SO4 is diluted to a volume of 500 milliliters. What would be the resulting concentration of the solution? So this one's a little bit different. Okay, in this one, they're asking you what the concentration is going to be. So you're starting with this, you're ending with this. So our M1 is 6.50. Our initial volume is 32 milliliters. Our final concentration is our unknown, and then our final volume is 500 milliliters. So again, to find M2, we are simply going to divide by the 500 milliliters. So 6.5 times 32 divided by 500 clearly is going to reduce that quite a bit. So our final concentration, remember our concentration was 6.5, and now it's all the way down to 0.416 molar. Okay? Okay, example 4. In an experiment, a student needs 250 milliliters of a 0.1 molar copper 2 chloride solution. A stock solution of 2 molar is available. Whenever they say stock solution, that's like if you go, like we call it the stock room, that's where we store all the chemicals. That's the one you're going to start with, okay? The stock solution is that beginning, the M1 or the V1. So the first thing we need to figure out, they want us to describe the steps the student should take to create this solution. So first of all, we need to figure out how much of that solution we're going to need. So M1 V1 equals M2 V2. Okay, and then to solve for V1, I'm going to divide by 2. So 0.1 times 250 divided by 2 equals, so V1 equals 12.5 milliliters. So describe the steps. So number 1, I'm going to add 12.5 milliliters of that 2 molar CuCl2 to a 250 milliliter. Remember, what's a good thing to use for measuring an exact amount? A 250 milliliter volumetric flask. And then number 2, I'm going to add water until 250 milliliters of solution is reached. Okay, or you could say whatever 250 minus 12.5, 237.5. You could say add 237.5 milliliters of water to reach 250 milliliters of solution. Okay, either of those ways would be fine. So when you're dealing with a dilution, what you're doing is you're taking a more concentrated solution and you're making it less concentrated. Okay, and the only equation that really you need to use is this M1V1 equals M2V2. Okay, the initial concentration times the initial volume is equal to the final concentration times the final volume.